in this session we will be discussing about limits and derivative. Before going into the topic, we need to know what actually a function is. Function is like a machine. For example, suppose when you tap the power button of your mobile, the mobile will switch off. Now, when you long press the power button, what will happen? The power menu will be appearing. That is, the restart option will appear. So, whatever the input you are putting, you will get a only particular output or fixed output. That's how the function will work. For each input, you will get a definite output. Now, when you are pressing the volume up button, there will be a certain function will be performed. That is, the volume will be increased. That's how the functions work. Now, we can discuss how it works in mathematics. Now, the thing is, suppose you are going into a stationery shop and buying a pen. In that scenario, you need to pay a certain amount, that is the cost of one pen. Total cost will be the cost of one pen. Let 10 is the cost of one pen into number of pens you are buying it. So if you are buying two pen, the cost will be 2 into 10, that is 20. Which means whatever the input you are putting to n, you will get a definite output, that is a cost you will be paying. For example, if you are buying 4 pen, then 4 into 10 will be 40 will be the cost you will be paying. That's how the function works. Now we can represent this scenario, that is the pen in, that is cost will be number of pen into 10 with our coordinate axis. In our coordinate axis, we will be using two variables, that is x and y. Let cost of pen will be y. No, total cost you will be paying will be y, and number of pen will be x. Number of pen will be x. In this scenario, we can frame a mathematical equation which with this, that is the cost you will be paying will be 10 into x, where x is the number of pens you are buying. For example, if you are buying 3 pens, the cost you will be paying is y will be the cost, that will be 3 into 10, that is 30. In this case, we have two variables, that is one of the variable is x and another variable will be y. Now, this x is an independent variable. That is, you can buy n number of pens. If you want, you can buy 5 pens. But when you buy 5 pen, how much you are paying? 5 into 10, that is 50. So, with respect to x, y is fixed. For a particular quantity, you need to pay a certain amount. That means this y is called a dependent variable and x is an independent variable. Suppose you are picking a random value, let you are buying 4 pen. In that case, y equal to 4 into 10. The total cost will be 4 into 10. That depends on this x. So in a function, there is one independent variable and one dependent variable. That's how the thing works. Now we can draw the graph. We already framed an equation, that is y equal to 10x. How does this graph look like? That means the graph looks like this. When you put x equal to 0, when x and y, when you put x equal to 0, when you put x equal to 0, you need to pay 0. When you buy 1 pen, you need to pay 10. So with the two points, you can draw the straight line. So the one of the point will be the origin, that is 0 comma 0. When you buy 0 pen, that is 0 rupee. When you buy 1 pen, you need to pay 10 rupee. Now with the 2 points, you can draw a straight line. Now if you are buying 2 pens, the cost you will be paying, how will you find the y value cost will be, this value will be reaching to 20. That is, this is x and this is y equal to function of x. Function of x means y is depend upon x. So you can write, instead of y, you can write it's a function of x, where it is 10x, f of x equal to 10x. That's how it look like. Now the thing is, this is how the basic logic works. Now we need to discuss what is meant by limit of a function. Limit of a function means, in the above scenario, I am taking the same scenario. This is applicable everywhere. Whatever the function is, it's applicable everywhere. Now we have the coordinate axis, that is x and y. You can say y marking as f of x itself, because with respect to x, y is changing. That's why we can call y is a polynomial of x or function of x. Now this is the graph. This is how it looks like. It's a straight line graph. This is 0, 0 origin. Now if you are buying 2 pen, what is the cost? The corresponding y value will be f of 2. Here it is y equal to 10x. According to our expression, it will be 20 rupees. This value will be 20 or f of. Now this 2 from the number line, in the number line you can approach 2 in two different ways. That is, here origin is there, 1, 1 will be there, and 3 will be somewhere here. From origin you can approach this 2, 0, 1. From origin you can approach this 2 in from this direction or from the right side of 2, which means you can approach this 2 either from its left hand side or from its right hand side. When you approach the value of function from left hand side, then we will be using the term left hand limit or LHL. Or if you are approaching from the right hand limit, we will use the term right hand limit RHL. This is LHL. Not LHS or RHS, it's LHL and RHL. Before discussing left hand limit and right hand limit, we can first discuss why it is needed. If you understand why it is needed, then it's easy to understand what does it actually means. Now you can have a function f of x equal to, we can define the function, that is the y value is equal to f of x, which is equal to 4 if x is always greater than 0. The output will be 4, and 0 if x is equal to 0, and minus 5 if x is less than 0. In this scenario, we can have that Cartesian plane, xy plane, where this is the our origin. Next, when x is a positive number, which means from 0 to infinity, that means without including 0, the value function is always a constant, which is equal to 4, that is from 4 to infinity. When x equal to 0, y value is 0, that is origin is another point. And when x is a negative number, the value of function will be changing to minus 5. That is, for negative values of x function will be always, the y values will be always minus 5. In this case, this function is a discontinuous function. Discontinuous function means where the values changes drastically. That, for example, if you take a number 0, 0 can be approached from both sides. That is we can approach 0 from a number that is slightly greater than 0, that is from 0.00000 etc. 0 1, or we can approach this 0 from this side, that is minus 0.0000000 etc. 1. So if you are approaching from this side, that is from positive side, the function's value changes, and from negative side the function's value exactly changes. So if the values are different with a small incremental value, the values increases and decrease drastically. In that case, the graph actually breaks. That's why the function forms a discontinuous function. Now, in order to check continuity, we actually use limits. Why? For example, if you want to check the continuity of a function, that is, if this is a continuous functions graph, you need to find the continuity at x equal to a. Then for x equal to a, there will be a value that will be corresponding values f of a. Now if you are going a slight increment means, for example, if a equal to 4, slight increment will be a plus, we will call it as a plus. A plus will be a value that is 4.00000 etc. infinite number of 0 1. That is a slight increment only. That's a number closer to 1. Now I am calling a number a plus that is closer to a, where we are approaching a from the right hand side, and another number which we are approaching a from the left hand side, that will be a minus. In this scenario, for a plus there will be a function, function will have a value that is f of a plus, and for a minus there will be another value that is f of a minus. These values are extremely small difference, only extremely small difference. In real life, the difference actually you can't notice, it will be closer. Here we have drawn with a significant difference, that's why we can notice this much difference. Now in this case, if these all three values coincide, that means if these all three values are together, the graph will be continuous. In the above case, the all three values, when a 0 is increased a little bit, that become a positive value. For positive value, the value drastically increased to 4. For a slightly negative value of 0, the value drastically decreased to minus 5. This is the two scenario. If the values are almost closer enough, then the graph will be continuous. Now for understanding continuity, for getting this value, we are using the term limit. Limit actually means, we can have another example that will be better. Now I need to find the continuity of this function. That is, I am taking y equal to 4x. Y equal to 4x. Now I need to check whether this function is continuous in at 4, continuous at 4, or continuous at 1. We can take 1. That's better. Now this will be actually give a straight line equation. You can plot with plotting 2 points, but this is how the graph looks like. Now I am taking a random point, that is 1. When I put 1, I got a y value, that is f of 1. But actually f of 1 indicate f of 1 equal to f of x equal to y, which is equal to 4 into x. So if you put 1, y value will be 4 into 1, that is 4. Now I need to check whether this function is continuous or something. For checking continuity, I will be taking the right hand limit. We are approaching from right hand. At that I will take a slightly positive value, that is 1 plus, and another value slightly negative value, that is 1 minus. This is the left hand limit, and this is from the right side. That's why it is called the right hand limit. If f of 1 plus, for this corresponding value there will be f of 1 plus, and for this corresponding 1 minus there will be f of 1 minus. If all three coincide, means the graph will not be breaking, which means everywhere the line will be continuous at that point. That's the logic. For finding f of 1 plus, actually what is f of 1 plus? F of 1 equal to 4 into 1, that is 4, because f of x equal to 4x. But actually what is the value of 1 plus? 1 plus is a value that is 1.0000000, infinite number of 1. So we can't identify the exact value of this x, because it is just a value slightly increased. We don't know how many zeros are there. Suppose you are telling this is the value of 1 plus, that is slight increment, then I can have one more value, that is this is the value, because it can, because from 1, if this is 1, if I say this is the value, 1.01 is a closer value, then I can have one more number by simply adding 0. 1.001 is more closer, because that is again closer to 1. Now again, if I take one more point, I can have 1.000001. This is more closer. So we don't have exact value. So we can't have a value for this. In that case, we will be only finding what value the function is approaching. That's the logic. In that case, we don't use this thing. We only use when x is approaching from the positive side, what is the value of function? That will be, function's definition will be given, that is 4x, that is limit x tends to 1 plus 4 into x, that is 4, which means we only know this value, the 1 plus value is approaching to 4. If the approaching value is closer, then the function will be continuous. Similarly, for 1 minus means a value slightly less than 1. In that scenario, I can say our 1 minus, that value, the slightly lower value than 1, can be 0.999. I can again give, that is from number line 1 is there. I can say this number is 0.999. Now we can have one more value which is slightly less than 9, that is 0.9999999. We can always have a closer choice to 1. In that case, we don't have a definite value to find f of minus 1. We don't have an exact value to find, because we don't know what actually the number is. In this case, we can find the limit, where what will be the value the function is approaching from the left side, that is what is the value of f of x if x is tending to 1 minus. In that scenario, this will be limit x tends to 1 minus 4x, which is equal to 4. Which means the thing is, we don't have the exact figures of this number. We can only identify when x is approaching that value, what will be the value of function. That's how much will be the function is approaching. That's the logic. Here again, I will illustrate with one more example. That is, suppose I am defining a function. For example, f of x equal to When x equal to 0, function's value equal to 0. F of x equal to 0 when x equal to 0, and x plus 1 when x equal to x is greater than 0, and x minus 2 when x is less than 0, negative number. In this case, I need to find the value of function to plot the graph. That is actually I am asked with a question whether this function is continuous at x equal to 0, that is origin. For that, at origin f of 0 equal to 0, that is given. That is at 0 origin y value is 0, 0 comma 0 is a point. Now we are taking a slightly positive value, that is 0 plus. In that scenario, this number can be 0.01. Again, if you take 0.01 in the number line, there will be another number that will be 0.001, or you can say like this, 0.01 is, or you can 0.01 is 1 by 100. 0.001 is 1 by 1000 will be there, more closer to 0. If you take 1 by 10,000, then it is again more closer to 0, that is 0.0001. In this scenario, we will have n number of values which is slightly above 0, but it is closer to 0. We can't find the exact value, because for exact value we need to find the value of this number, but this number has infinite choice. So we can have only one option. We can find the approximate value of, that is right hand limit, that is when x is approaching from 0 plus, what is the value of function where the function is approaching. In that scenario, limit x is tending to 0 plus, f of x value will be, when x is positive, f of x value will be x plus 1, x plus 1. That is when you put the value 0, you will get 1. Actually, then value will be, the exact value will be 1 plus x. X can be 0.0000 etc. 1, but we don't have a fixed value how much zeros are there. So that's why we can only find the around approximate idea to what value the function is converging, or what value the function is going towards. That's the logic behind the limits. In this scenario, when x is a slightly greater value, that is 0 plus a positive value, while using this one, this function is somewhere around 1, and it will go like a straight line equation. Again, now we are approaching from this side, from left side. From left side, we can have f of 0 minus a value slightly less than 0. But we don't know this value, actually this value is, because if you take 0, 0. Here minus 1 by 10, if I say 0.1, that is 0.1 is the smallest value, minus 0.1 is the smallest value. But I can have one more option, that is minus 1 by 100 can be the value, that is minus 0.01 can be the value. Or if I fix this as a minimum value, again one more minimum value exists when I add again 0. In that scenario, minus 0.001 will be there, which means we can have infinite choice where the number is tending to 0. We can have a lot of number slightly less than 0. In that case, we can't have an exact value for the 0 minus, because 0 minus means that number is closer to 0 but a negative number. In that scenario, we can only find where the function will be approaching when you put a slightly less value of 0, that is f of 0 minus. This is called a left hand limit. We are approaching the function from the left side of the number line. In this case, it will be limit extends to 0 minus. Our function definition was, if x is a negative number, it is actually x minus, that will be minus 2. So we have minus 2 over here, and it will be somewhere a negative line will be there, x minus 2. So it will be like this. So here left hand limit and right hand limit and f of a are different. So the graph just break, because we can't find the exact value at that point. Now we can have one more equation, example. Now we can take this as the graph. In this scenario, the function is a constant function, or you can say aka parabola. Parabola y equal to x square, because our quadratic equations are parabola. This is the graph, y equal to x square graph. In this case, y is a function of x. I need to check the continuity at this point, or I need to find the continuity or the value of function at this point, x equal to at x equal to 2, f of 2 will be what? 2 square, that is 4, because function is y equal to x square. Now I need to find the value of function which is slightly greater than 2, that is 2 plus a slight increment from 2, that is the we are approaching from this side, a value which is so much closer to 2, it's slight only a minute increment. In that case we are approaching from the right hand side. But this value, can you directly put this f of 2 plus? Because if you take 2.001 is the closer value to 2, then I can have one more option. This can be the number, or this can be the number. So this number is uncertain. We have multiple options for that number. So we can only find the idea. If we approach that function, left hand limit, when you approach that function from slightly greater value from 2, the function value we can put it as 2 square, that is also closer to 4. That's how it works. Similarly, when you approach from a value f of 2 minus, 2 minus means this number is slightly less than 2. Why? This number can be 1.9, it is closer to 2. This number can be 1.99, more closer to 2. Again 1.99999, again more closer to 2. So if you take one number, there will be always a next number. So we don't have exact value of the that function a slightly less than 2. At that time, we can only have left hand limit. Left hand limit. This is right hand limit, sorry, because we are approaching from here. That is left hand limit. And left hand limit, we can find the limit of the function. That is the value of function which is approaching what value? That is limit x tends to 2 minus f of x. That is x square. Limit x tends to 2 minus. That will be 4. The function is approaching 4. If these values coincide, then our graph will be a continuous graph. That's the significance of having limit, which means limit if the limits are closer, that is if limit x tends to a plus f of x equal to limit x tends to a minus f of x, which is equal to f of a, then these 3 points almost coincide. When points coincide together, we will have a continuous graph. That's the application of limit, which means we can find the value of that function when it approaches a certain value. Or you can understand like this also. For example, a function f of x equal to x square. Now I am telling the value of function when it is slightly positive, slightly positive. In that case, the slightly positive means we are considering the smallest possible number we have. So can it be this, or can it be this? If you are fixing this on, again there will be one more number which is more closer to 0 and it is positive. At that time we can't find the exact value of this function. In that case, we can only find where the function is going, or the value of function will be finally going. In that case, we can have limit, that is limit x is tending to 0 plus a slightly positive value. What is the value of function which is approaching? In that case, limit x is tending to 0 plus our function is x square. The value of function is approaching 0. That's all. Because here also, if the value is 0.0001, when you square it, it is 0. How many? 4. So it will be 8. So this is approaching 0. That's the only thing we can find. That's the significance of having limit. Now again, in this function, the LHL and RHL are not coinciding. If you take a slightly positive value, you will get this value as function. When you take a slightly lesser value, you will get this one. So here right hand limit and left hand limit are separate. But in this case, left hand limit and right hand limit, everything is giving you 4. In this case, you can simply say limit x tends to a f of x. You can come club together. Don't need to take it separately.